Okay, so to find out what's going on in this situation, we need to solve the equations of motion. Step one is choose our coordinates. Now, choosing our coordinates is a very important part of the process because it really sets up exactly the structure of the problem. So I need to know where this block is. I know it's going to be sitting on the ground on this surface somehow. So I'm just going to have to label its position from some initial point, and I'll call that Q1. I need to know where this block is, and I have lots of choice. I could have its position from that same place, but actually I'm going to label it from the bottom of this up there at Q2. Notice I've done my labeling on my diagram, so I know exactly what things are. When I look at this, I realize I'm going to need to know this angle in order to solve things, so we'll just put in the theta there. And I'm going to need to know the masses of these two things, so I'll call this block 2 and I'll call this block 1, M1 and M2. Okay, looking good. Step 2, find our Lagrangian in terms of these coordinates. Now our Lagrangian, remember, is the total kinetic energy minus the total potential energy. Now the total kinetic energy of this block is going to be a half m1 times its velocity squared. Its velocity, it's just going to be traveling in this direction, so its position is q1, its velocity is going to be q1 dot. So the kinetic energy of that block is simply a half m1 q1 dot squared. The kinetic energy of the second block is a little bit more complicated. Its x-coordinate, okay, if we think of this, there's our x2 and there's our y2. So its x-coordinate is a bit more complicated, isn't it? Its x2 is going to be, well, it's just going to be q1, but we're also going to have a contribution from q2, the cosine part of it. y2, so the height of that block is going to be q2 sine theta. Now, how do we get the velocity from that? The velocity we happen to know is just simply a half m2, and we know it's x2 dot squared plus y2 dot squared. So I know the kinetic energy in terms of the Cartesian coordinates, and I can, because I know how the Cartesian coordinates can be represented in terms of my generalized coordinates, I can get the whole thing. So we need to take away the potential energy as well. The potential energy of this block never changes, so we'll just set that to 0. The potential energy of this one does, however, as Q2 goes up and down, this goes up and down the slope. So we've got minus m2 times g times the height, which is just going to be, again, our y2. Now I need to get these things in terms of the generalized coordinates. If I go here, I've got x2 dot is going to be, taking the derivative of this, it's going to be q1 dot. And theta doesn't change, so it's just going to be plus q2 dot cos theta and y2 dot. So down here I have, and noting we have a cos squared and sine squared term, and cos squared plus sine squared equals 1. We have the Lagrangian. So now that we have the Lagrangian, we effectively have everything we need to calculate how these things behave, and they behave according to the two Euler-Lagrange equations. Ba-bam. Okay, so we need to be able to take this derivative, so we've got a q1 dot term there, there, and there. So we're going to get 3 terms. And we have a q1 term nowhere. In terms of q2 dot terms, we have 2. We have 1 there and 1 there. And q2 straight terms, we have this 1. Notice I've got a minus from there and a minus from there, so it's going to give me a plus. Okay, so we've got our 2 equations. We can simplify, tighten a little. So there are our 2 equations of motion, and all we have to do is solve those 2 equations of motion, and we have the answer. Now before I leave this problem, I'm going to check that what I have here makes some kind of sense. Okay, let's look at the limit. What limits do I know? If I go back up to my original picture, it's kind of obvious that if I have theta equals 0, then these two things are just going to be unaffected by gravity, so they're not going to accelerate at all. They're just going to travel on at whatever speed they were going before. I come back down to the equations. I see when theta equals 0, I have this term is 1, and so I just have m2 times the sum of the accelerations, and m1 times the acceleration is 0. When that is 1 and that is 0, then what I have is that if I solve those two equations, I get that the two accelerations are 0, which is exactly what I expected. Okay, now let's look at the other example when, say, the angle is 90 degrees. In that case, I would expect their x velocity, so the q1 wouldn't accelerate at all, but the q2 would fall at a speed g. So in that case, I would have that being 0. So I would have q1 double dot is 0, just straight from that equation, which is exactly what I'd expect. And then coming over here, this would now be 1, so I'd have m2g. That would be 0, so I'd have m2 q double dot equals minus m2g.